So you want to learn machine learning, right? But maybe you feel like you're just stuck. You're swimming in a sea of online courses, getting tangled up in all the complex math, and honestly, you're pretty close to just giving up. Does that sound familiar? Well, today we're going to cut through all that noise. This is your guide, a structured, no-fluff path to learning machine learning in a way that actually sticks. Let's get into it. And look, this quote right here, this is so common. You start a course, you get totally bogged down in dense theory, and you start wondering if you're even smart enough for the stuff. And before you know it, just like the quote says, months have gone by with nothing to show for it. It's a really frustrating cycle, and it's why so many talented people quit before they even get started. So the big question is, how do you avoid that trap? Well, the key isn't about being some kind of genius or finding a secret shortcut. Nope. It's about having the right map and following a structured path, one that builds a rock-solid foundation before you even think about touching a complex algorithm. And that is exactly where we're going to start. You see, the reason most people fail at machine learning is because they skip this first crucial step. It's like trying to build a skyscraper on sand. We are not going to do that. We're going to build our foundation on solid rock. Machine learning is built on three and only three fundamental pillars. I want you to think of it like a three-legged stool. If any one of those legs is weak or, just missing, the whole thing is going to crashing down. You just can't skip one and hope the other two will hold you up. It doesn't work that way. So what are these magical pillars? Well, you can see them right here: mathematics, statistics, and programming. For math, we're talking about the essentials: linear algebra, calculus, and probability. For statistics, you've got to know core concepts like mean and hypothesis testing. And for programming, it is all about Python and its powerful ecosystem of data libraries. I know what you're thinking. Ugh, do I really need the math? And the answer is absolutely, 100% yes. You need linear algebra because all your data is going to live in matrices. You need calculus because that's literally how models learn, through optimization. Probability helps you make sense of a model's confidence. And statistics, that tells you if your results mean anything at all. Without these, you're just blindly copying code and you won't get very far. Okay, so where do you get these skills without spending a fortune or going back to school? Easy. Khan Academy. It is completely free, the explanations are incredibly simple, and, this is the most important part, they have practice exercises to make sure you're actually getting it. Now for our second pillar, programming. And in the world of machine learning, there is one language that is the undisputed king of the castle, and that is Python. It's not even a debate anymore, folks. And here's exactly why the entire community has rallied around it. First, its syntax is simple, so you can focus on the problem, not on fighting with the code. Second, it has these incredibly powerful libraries built specifically for data and ML. And third, the community is just massive, so whenever you get stuck, and trust me, you will, help is just a quick search away. Here is your exact path. First, start with the basics, variables, loops, functions, at a site like learnpython.org. Then you've got to master the essential libraries: NumPy for super fast math operations, and Pandas, which is an absolute must for cleaning up the messy, real-world data you'll be using. And finally, learn Matplotlib and Seaborn to actually see the patterns in your data. And again, no need to go hunting for a bunch of different resources. The Data Analysis with Python course on FreeCodeCamp's YouTube channel covers all of these data libraries in one single place. It uses real projects, and yep, it is completely free. Okay, with our foundation of math and programming built nice and strong, we are finally ready for the main event. Now we can start building on top of that foundation and really dive into the core concepts of machine learning itself. So broadly speaking, ML is broken down into a few types. The most common one is supervised learning. That's where you give the algorithm data that already has the right answers, or labels, like a bunch of photos tagged as cat or dog, and it learns to make predictions. Then you've got unsupervised learning. Here there are no labels. You just give it a ton of data and it finds hidden patterns all on its own, like grouping customers into different types of shoppers. And the third major type is reinforcement learning. Think of this as literally learning by doing. An algorithm takes actions in some environment and gets rewards or punishments for those actions. Over time, it slowly figures out the best strategy through pure trial and error. This is the magic behind AIs that can master complex games, and it's the brains inside self-driving cars.
So, how do you learn these concepts the right way? The absolute gold standard, hands down, is Andrew Ng's machine learning specialization on Coursera. And the reason it's the best is captured perfectly in this quote. He builds your intuition for why something works before he ever shows you the math. And that right there makes all the difference.
Okay, once you've mastered the fundamentals of machine learning, you're ready to tackle its most powerful and, let's be honest, most exciting subfield, deep learning. This is the stuff that powers all the revolutionary AI breakthroughs you read about every day. At its heart, deep learning uses these things called neural networks, which are kind of inspired by how the human brain is structured. They learn through this really clever process called backpropagation, which is just a fancy way of saying they learn from their mistakes. And within deep learning, you have special networks like CNNs, which are geniuses at understanding images, and RNNs, which are designed for handling data that comes in a sequence, like text or speech.
And who better to learn from than the same guy? Yep, Andrew Ng's follow-up deep learning specialization is the perfect next step. And the best part is that it's not just theory. You'll be building real-world projects, like actual face recognition systems, using TensorFlow, which is the industry standard.
But here's a really crucial reality check. Just watching courses is not the same as learning. True, deep understanding only comes when you get your hands dirty, when you hit a wall, when you have to debug the problem, and when you actually build something yourself. So you need a project path to follow. Here's a great one. Start with a classic beginner project, like predicting house prices from a dataset. Then move up to something intermediate, like building your own movie recommender system. And finally, really challenge yourself with an advanced project, like building a system that can detect objects in a live video stream. This progression is what builds your skills. All right, the final piece of the puzzle. It isn't another course or a project. It's a mindset. You have to understand that machine learning is a field that evolves at lightning speed. What's state-of-the-art today might literally be obsolete next year. Now, you don't need to read every single new research paper. That's impossible. Instead, just build a simple habit. Spend 30 minutes a week, maybe on a Friday afternoon, on a site like Hugging Face, and just skim the summaries of the new trending papers. This simple little habit will keep you in the loop on what problems people are solving and the new ways they're doing it. And that brings us to maybe the most important takeaway of this whole thing. You cannot rush this. Don't skip the fundamentals. Because every little shortcut you take at the beginning is going to cost you big time later on. Embrace the process and just understand that this is a long-term journey of continuous learning. So there you have it. You now have a clear, structured roadmap that has worked for countless people. The path from zero to building real ML systems is laid out right in front of you. The only question left is, what are you going to build first?